All right, boys and girls, this is Math Message 7-3, and in this math message or this math lesson, we are going to work to solve number stories or word problems about time, mass, volume, and length. Remember what mass means? Mass is the same thing as weight. And remember what volume means? Volume is the same thing as capacity, or how much a container can hold. So I need you to make sure that you have scrap paper ready to go or a whiteboard, because we're going to do several problems before we get into our workbook. So if you need to pause the video, go ahead and do that. All right, the first problem that we're going to work on is about time. So let me read the problem to you, and then I want you to pause the video and see if you're able to solve this problem, and then we'll go over it together. So it says that Sanjay catches the bus at 2:05 p.m. It takes him 40 minutes to get to hockey practice, and practice starts at 2:30 p.m. So how many minutes late will Sanjay be for practice? So be real careful when you're looking to answer this problem. Usually when we solve problems with time, I always tell you that there is a beginning time, ending time, and then there's that time in between. That's how much time we're jumping, or the elapsed time. Now, usually I give you two pieces of information and you have to solve the third. So sometimes I might give you the beginning and the end, and you have to tell me how much time is in between. Sometimes I might give you the beginning and how much time it took, and you have to tell me the ending time. And sometimes I might give you the ending time and the time in between, and you have to tell me the beginning. This problem here, there's a lot going on. It tells me that Sanjay catches the bus at 2:05. It tells me it takes him 40 minutes to get to hockey practice, and that practice starts at 2:30. It's not necessarily telling me it's 40 minutes until 2:30. What it wants to know is how many minutes late will Sanjay be for practice. So it doesn't want you to tell me the ending time. It wants you to tell me how late will he be. Go ahead and pause the video and see what you come up with. Okay, so again in this problem, I'm going to go ahead and I'm going to write down what time Sanjay catches the bus. He gets on the bus at 2:05. Now it says it takes him 40 minutes to get to school. Now sometimes we might need to break that time down because it might be easier to do that. But in this problem, I don't think that's going to be very hard at all. We're at 5 minutes now, and when we add another 40 minutes, what time will that be? That's pretty easy math, right? 5 plus 40 is 45. It didn't change to a new hour. Remember, when it gets to 60, it changes to a new hour. That didn't happen. So 2:45 is the ending time. That's what time he's going to arrive at practice. Now here's the problem. It said that practice actually started at 2:30. So I'm going to kind of back it up here. 2:30 comes before 2:45, right? It wants to know how late will he be. So you needed to actually find this time, the time between what time practice started and what time he actually got there. Now again, this is pretty easy math as far as the time. These are our benchmark times. It gives me 30 minutes and it gives me 45 minutes. So this should be pretty easy math to figure out how much time between 30 and 45. So Sanjay will be 15 minutes late for practice. All right, let's look at the next problem. Okay, skip that page there. All right, so this problem is about what? If we're talking about, so it says a sip of water is about 10 milliliters. About how many sips would it take to drink 130 milliliters? So what kind of measuring are we talking about in this problem? When you see the word milliliters, or this is the abbreviation ml for milliliters, we're talking about volume or capacity, okay? How much liquid something holds. All right, so let's look at this problem. A sip of water is about 10 milliliters. So if you think about it, I'm just going to kind of draw a little bit of a cup here. And it says a sip of water is about 10 milliliters. About how many sips would it take to drink 130 milliliters? I want you to go ahead and pause the video, think about this, and see what you come up with. All right, so what kind of math are we doing here? Kind of like multiplication, right? How many of these, how many times will I have to take a sip of that so that it gets me to 130 milliliters? Okay, so how many times will I have to take a sip of 10 milliliters to get to 130 milliliters? Well, we know that when I multiply by 10, put a 0 on the end, right? So 10 times 13 would give me 130 milliliters. So is that what you came up with? If so, great job. And again, if I were writing this answer down, I would say 13 milliliters, and I can abbreviate my milliliters that way. All right, let's look at the next problem. All right. This time it says a runner takes larger sips after a race, which makes sense, right? You're usually gulping down your water. She drinks about 20 milliliters per sip. So how many sips does she take to drink the 180 milliliters in her water bottle? Go ahead and pause the video and see what you come up with. All right, so again, this time I like to draw pictures because that really gives me a visual and helps me kind of understand it. So this time I'm thinking of 20 mLs. That's my sip of water. And I want to know how many times I'll have to take that sip of water so that I will drink my 180 milliliters. Okay, so 20 times what equals 180? How could you figure that out? I noticed that both of them end in a 0, so I could kind of probably forget about that 0 for a minute, right? 2 times what is 18? 2 times 9 is 18, and so 20 times 9 would be 180. Okay. Or I could even skip count. 20, 40, 60, 80, 100, 120, 140, 160, 180. And so I have 9 times 20 equals 180 milliliters. All right. So now let's look at some word problems in our workbook. I want you to go ahead and turn to page 224 in your workbook. That is lesson 7-3. I want you to go ahead and work on this page, and I believe there's another page, the next page, 225. Go ahead and work on these 2 pages, pause the video, and then come back and we'll check them together. All right, so I hope you gave yourself time to solve these problems. Remember, boys and girls, it is only going to help you if you actually really try to do the work on your own. And then just use the video to help check yourself. All right, so let's look at number 1. It says that Kiana has 40 inches of green ribbon. She wants to cut it into 9 4-inch pieces to make Earth Day award ribbons. Does Kiana have enough ribbon? Now, if you know me very well, you know that when I have word problems, I draw a picture. Okay, so I know that it says Kiana has 40 inches of green ribbon. Now, of course, I'm not going to be able to draw actually 40 inches of green ribbon because that would take up a lot of space, right? So I'm just going to draw a line that's going to represent my ribbon. And I might even put on here 40 inches. That way I know from here to here is 40 inches. Now, the next part of the problem says she wants to cut it into 9 4-inch pieces to make Earth Day award ribbons. Okay, so she wants to cut it into 9 4-inch pieces. It wants to know if she has enough. So I'm going to start cutting it into 4-inch pieces. Okay, so here's 4 inches. There's another 4 inches. Now, what would that be? That would be 8 inches, right? And then she's going to cut another 4-inch piece. That's going to be 12 inches. She's going to cut another piece. That's going to be 16 inches. And then she's going to cut another piece. That's going to be 20 inches. And I'm going to need to keep track of how many pieces she's cutting as well. So she wants to cut 9 4-inch pieces. So there's 1 piece. 2 pieces, 3 pieces, 4 pieces, 5. All right, let's keep going. So here's my 6th piece. I'm up to 24 inches. Here's my 7th piece. I'm up to 28. Here's my 8th piece. I'm up to 32 inches. And here's my 9th piece. And I am up to 36 inches. Now I have 40 inches, right? So I was able to cut I was able to cut 9 4-inch pieces, and I had enough ribbon. So the question is, does Kiana have enough ribbon? My answer is yes, she has enough, right? How much ribbon, if any, would she have left over? So once I cut my 9th piece, I was at 36 inches. So how many pieces or how many inches does she have left over? And she would have 4 inches left over. And make sure that you're labeling your unit so I know what you're talking about. All right, let's look at number 2. The city zoo is home to a male African lion. After the lion arrived, he gained about 8 kilograms of mass each month for 8 months. He now has a mass of about 186 kilograms. What was the lion's starting mass? All right, if you have not solved this problem yet or tried to, I want you to pause the video first. But if you've already attempted it, let's look to see how well you did. All right, so again, let's see if I can start drawing a picture. A city zoo is home to a male African lion. After the lion arrived, he gained about 8 kilograms of mass each month for 8 months. So I know he gained 8 kilograms. Okay, and that's how much he was gaining each month for 8 months. So this happened for 8 months. So 1, 2, 3, 4, 5, 6, 7, 8. Now, I know that 8 times 8 is what? 8 times 8 is 64. Now, that's how much weight he gained. Okay? It says he now has a mass of about 186 kilograms. What was the lion's starting mass? It's kind of like one of those start, change, end. That reminds me of a start, change, end diagram, doesn't it to you? So I started with something happened to it, and then I ended with something else. So what was his starting mass? That's what I'm trying to find out. I don't know what he started with. But something happened to his weight. What happened? He was gaining, right? How much did he gain? Well, we know that he gained 64 kilograms because we did the math of that part, right? And then what did he end with? We know he now has a mass of 186. Okay, so here's my number model right here, guys. What plus 64 equals 186? I have to figure out what I started with. When I add 64, I get 186. Well, I know that I can turn this around into subtraction. I can take my 186, I'm going to kind of come down here, I'm running out of room, minus my 64, and that will give me his starting weight. So when I do the subtraction of that, I know that he weighed 100 kilograms. Now, I'm going to check my work to kind of see if that makes sense. Does it make sense that if he started at 122 and he gained 64, will he end with 186? I'm going to do the math. 4 plus 2 is 6, 6 plus 2 is 8, and 1 plus nothing is 1. So yes, my answer makes sense. All right, let's look at number 3. It says Lena has a doctor's appointment at 8:45 a.m. It takes her 25 minutes to drive to her doctor's office. How many minutes early will Lena be if she leaves at 8 o'clock a.m.? All right, so we got to figure out all these parts and pieces here. Again, if you haven't already tried to solve this, pause and try to do that. So I'm going to draw my timeline. And let's see here, I've got the time 8 o'clock, 8:45, and I've got an elapsed time of 25. So I know I need to put my starting time here at 8 o'clock a.m. Now, that says that's what time she leaves her house, at 8 o'clock a.m. So I'm going to write leaves. Now, it says it takes her 25 minutes to drive to her doctor's appointment. So if I'm driving for 25 minutes, this is pretty easy math, right? 8 o'clock plus 25 more minutes, that means I'll get there at 8:25. Now it says her appointment is at 8:45. So 8:45 is after that, isn't it? So I'm going to go ahead and put my 8:45 there. It wants to know how many minutes early will Lena be. So this is what time she's getting there. This is what time she needs to be there. How early is she? My hours are the same. I know all I'm looking at are my minutes. So 25 plus what will get me to 45? 25 plus 20. So she's there 20 minutes early. And that's my answer. Okay, it says at what time must Lena leave to arrive at exactly 8:45? So let's see if I can't get my screen to go down any farther than this. I don't know how to get that. There used to be a little button that I could do that. So I'm going to go ahead and erase this work I have up here so that I can redo that part of the problem. All right, so at what time must she leave to get there at exactly 8:45? So now I'm going to put my 8:45. That would be my ending time. Now I still know that it's 25 minutes. So it wants to know what time does she have to leave her house. This time, guys, I am going back in time. She's at 45 minutes. I need to subtract 25 minutes. So 45 minus 25, and if you can't see it, feel free to go ahead and rewrite the problem so that you can see it better. Okay, some people are so good at doing this in their head, but I need, so 45 minus 25 would give me 20, right? That's the time, so 8:20, and let's go back and see if that makes sense. So 8:20, leaving the house, plus 25 minutes, 20 plus 25, will indeed get me there at 8:45. So she must leave the house at 8:20 a.m. Okay? All right, let's look at the next problem on the next page, number 4. It says for problems 4 and 5, use pictures to help you solve. How much more liquid is in beaker B than in beaker A? So we need to look at these beakers. Now look at the scale of what they're counting by. You can see 100, 200, 300, 400. It's counting by hundreds. And so in beaker A, I've got 500 milliliters. And in beaker B, You can see it's between 600 and 700. So what would that be? 650, right? It wants to know how much more liquid is in beaker B than in beaker A. So you can either think of it like 500 plus what equals 650, or anytime we have those how many more problems, we can subtract. We can take our 650 minus our 500, and that will give us 150 milliliters. There's 150 more milliliters in beaker B. All right, and then finally, number 5, it says Thomas wants to figure out the liquid volume of his glass. He fills a 50 milliliter beaker with water and empties it into his glass 4 times. His glass is now full of water. Then Thomas empties his glass into a 1-liter beaker. Shade the beaker to show how much water is in his glass. Okay, so he wants to figure out the liquid volume of his glass. So I'm going to draw his glass just to help myself think about this. It says he fills a 50 milliliter beaker with water. So here's my 50 milliliter beaker. It says he fills that with water and empties it into his glass 4 times. Okay, so 50 times 4 equals what's in that glass. So what is 50 times 4? Well, 50 times 2 is 100, right? So 50 times 4 would be 200. So Thomas's glass holds about 200 milliliters. And it wants us to shade the beaker to show how much water is in his glass. So you just need to, boys and girls, come over here and shade that in to show how much water is in his glass. All right, guys, that is it for math lesson 7-3.